all, I'm Sachin, founder of Trojan Vectors, and we perform rack security as plenty of speakers before me told you about amazing things which AI is gonna do for us and probably is doing us even now. I'm gonna show you how AI secure, how attackers can corrupt these AI applications and like make our lives harder and what we should do to prevent attackers from doing that. So, before we jump into that, let me ask you guys one question. How many of you have eaten your uh, today's daily quota of stones? Do you remember this Google AI overview example where Google AI overview asked people to consume at least one small stone a day? This is among the first examples of indirect prompt injection. This was not malicious, only hilarious, but attackers can take such examples and do wild things. We will show you some of the wild things which we have done as proof of concepts over this thing. But before that, I want to ask you, how many of you know what rack systems are and how we build them? Few, not many. So I'll just give a brief overview of that. So this is how we interact with large language models like ChatGPT or Claude. User has a question, user asks the question, LLM gives the answer. Simple. But when you have your custom data, then systems look somewhat like this, where we, along with LLM, sorry, we add vector database as well. So user asks a question, then LLM searches for the answer from vector database. Vector database sends a document, and then LLM generates the answer from that document and passes it down to the user. This is how RAG is. This is how RAG works. And Bayang showed us how in source graph they are using RAG systems to do such cool copilots. So let me show you what most of the AI security right now is, which is mostly direct prompt injections or jailbreaking. User asks AI, hey, how should I make a bomb? And probably large language model is not going to answer that question. And then user will ask some sort of obfuscation code, something such that it will force LLM to generate the answer. And LLM will give the recipe of this is how you should create a bomb. Is this harmful? Maybe we will see. Is this the worst thing which can happen or something much worse can happen? So let's add an attacker apart from user in the picture. Attacker adds a malicious document in the vector database. How attacker adds that, we will discuss later. But for a moment, let's imagine attacker adds a malicious document in the vector database. Now, user asks a question, and this question is pretty legit, and wrong answer here can be life-threatening. That, hey, which medicines should I take for my diabetes? LLM searches for diabetes medicines, but now as attacker has added this malicious document, vector database will return this particular malicious document among other correct documents to the LLM. But because of this malicious document, LLM will generate wrong medicine as an answer. This is much more threatening, right? So the comparison between direct and indirect prompt injection, the way I see it, is in direct prompt injection, user is trying to make chatbot say something which is not correct and then be like, oh, it tripped. Yeah, it will have some PR issues and maybe name of your someone will take the screenshot and hey, this particular chatbot said these racist or sexist things, but that's a PR issue. No direct harm has happened. And if user is making a bomb, then probably I'm not saying anymore. In the next case, here user is doing their own work. They want the chatbot to just operate, but a separate attacker is coming in and disrupting the user's use case. Here, app developer is benign, user is benign, but attacker is malicious. And this sort of attacks are even harder to recognize because most of the times ChatGPT or Google Gemini gives us an answer and we are quite okay. We trust it somewhat implicitly, unless it is egregious, but usually we trust it somewhat implicitly. Couple of real world implications of this can happen, like loss of life, which we looked, and then financial losses, legal repercussions, and a lot of these other things which can happen. Now let me just talk about bunch of myths in AI security, and we will address couple of concerns about this particular attack through these myths. First myth is GPT models are inherently more secure than open source models. I think this is a wrong understanding, and like either because of some commercial interests or because of like wrong understanding, this myth gets propagated. Second is our database is secure. We have firewalls and attacker cannot put anything in our database. I'll show you how both of these myths can be broken quite easily. So myth one is like open source models are insecure. Closed source models are like pinnacles of safety, and Azure OpenAI is going to take care of all of our security problems. Let me show how that's not the case. Just a moment. Yeah. Mm. Yeah. So I'm not going to run all of this entire notebook right now, but this notebook is available on my GitHub repository. Please feel free to recreate this particular sort of attack and see how this harm can happen. But I'm just going to show you how these things usually happen. Imagine this is our small set of like database where we have around 10 documents of financial nature, and we ask how much did revenue increase, and we add some attack document which is about like Nina watching her cat curiously paw at some things. Like it has some revenue somewhere, but it doesn't talk about how much revenue increased. We add all of these documents in our vector database. There is a system prompt, and before adding like poisoned example, we ask the question to our chatbot. This is like pretty basic RAG chatbot implementation. How when we ask how much did revenue increase, it retrieves the correct document and answers the question by 15.38%, which is the correct answer. Now let us just add the poison document. Here we just add documents plus attack document. So we have added poison document now. And when we ask this question again, and here we are not just retrieving single content because we don't want to give a leg up to the attacker. We are having pulling bunch of different contexts, like bunch of different documents. So when we ask the same question, it picks up these two documents, which is Nina watched her cat and the CFO Robert, which is the correct answer. And still it hallucinates that the revenue increased by 42%. So attacker is able to do these things. Let me just share the slides again. Second is like our vector database bases are secure. Like this is what I have heard from like most of my customers, that hey, we use like trusted data sources. Like all of our data sources are like our internal ones. So also we have firewalls in our for our existing applications. Like how can an attacker come and insert malicious document in our secure databases? So let me show you like how the malicious strings look like. If you read this particular string, it is random noise, like bunch of words. An attacker can hide this string in either putting it in white font or like putting it in extremely small letters or somewhere, and bury it in like a document which has like 10 pages or something like that. And when companies has like around millions and like millions of documents, like having one such document where there is one small string is not impossible. And this particular document forces the chatbot to hallucinate the answer that the common claims for travel insurance are travel insurance international coverage are ice, fire, and other related incidents. If you look at the string, like it doesn't say anything like that. This example is also available on my GitHub. So please feel free to check the GitHub and like reproduce this particular error. So as I said, like as companies will have millions or like sometimes even billions of documents, and hiding these two lines somewhere isn't hard. Your documents are stored in like Google Drive, like S4, and like at lots of different places. Attacker can like do some sort of social engineer in your like company's one of the employees by sending them otherwise pretty legit document and hiding these two lines somewhere in that otherwise legit document. And that's how they can poison your vector databases. Otherwise, if they know from where you are gonna like curate your data sources, what sort of like uh, policies or what sort of things you are extracting from the World Wide Web. Like attacker can poison that well and poison in like in turn your vector databases. So real world example, we showed that this like till now whatever I showed was in like my own like created like RAG data like RAG chatbots. We showed that it's not possible only in like a case where like we build the RAG chatbots and we break them. We have showed that this can happen with Notion AI as well. This is a proof of concept example where like document about like bomb sniffing dogs made Notion AI hallucinate like their some companies' revenue numbers. Some other company last week showed that this sort of attack can happen with Microsoft Copilot as well. So we talked a lot about these attacks, and like as Danny had mentioned that we are still at the early stage of the cycle. As we use more and more Gen AI, like the way we started to use more and more web, the attackers figured out different ways to corrupt these things. So these attacks will get more and more sophisticated. We should be ready with the prevention techniques. So let me just talk about how if an attacker is going to come at you with this sort of indirect prompt injection, how a developer or how a company can prevent these attacks from happening. First, like obvious answer everyone thinks is like we will adjust guardrails. Everyone adds guardrails, right? The problem with this particular sort of attack is that these questions are genuine because user is asking a genuine question. The answer most of the times look like a genuine answer. So for these guardrails to identify this particular attack is nearly impossible. But we can do something better. We can have a vector guard, which is a guardrail on top of vector database. So when attacker is trying to insert something in the vector database, we stop them right there in the tracks. Also, like having such vector guard, the advantage is there is zero increase in the latency. And there is some sort of like continuous monitoring and human supervision will help us prevent these attacks. So the conclusion is most of the RAG chatbots today are insecure. We showed this with Notion. Someone else showed this with Microsoft Copilot. And these insecure RAG chatbots can cause huge problems to the consumers. But we have solutions and we can easily prevent these malicious attacks by like implementing these robust security measures. And that's all. Thanks a lot, guys.